Hey, in this video, let's quickly go through the operators available with Java. Okay, so the basic skeleton of my program is already ready. My class name is operators, and I've saved the file as operators.java with the class name. Okay, so let's first declare some variables. Say int um, a, b, c. Okay, so let's first look at the assignment operator. Okay. So my equal to symbol is my assignment operator because I'm assigning the value 2 here to my variable a. Okay, so that's the assignment operator. And then we have arithmetic operations. Okay, arithmetic operators. So let's say b is equal to 5. Now if I say c is equal to a plus 5, this is my addition operator. Okay, it's basically doing the job of addition. Okay, and then I just print it out. System.out.println a is equal to plus a plus b is equal to plus b plus c is equal to plus c. Okay, let's just copy this set of statements, okay, so that we can just use them repeatedly. So we have plus, we have minus, minus is for subtraction, and then we have multiplication, and then division, and then the modulus operator, which returns the remainder, okay. Division returns the quotient, whereas modulus operator would return the remainder. And we also have the increment and decrement operators. You must be familiar with post increment, pre increment, and post decrement and pre decrement, right? So let's just try them out. So let's try pre increment here on C. So increment is done with plus plus, which is basically equivalent to plus 1, okay? But the difference between pre-increment and post-increment is that in case of pre-increment, you first increase the value. That means you add 1. Like in case of this particular statement here, we're adding 1 to C, okay? This is same as um, C is equal to C plus 1. Okay. So when you do pre-increment, you're first increasing the value of C by 1 and then performing the other actions in that particular statement. Okay. Whereas in case of post-increment, you first finish off this statement and then increase the value of C with 1. C by 1. Okay. So let's just save it till here and it. So Java C operators.java. Okay, we have some errors. Okay, parenthesis is expected towards the end of the statements. Save it and compile it again. Yep. Then Java operators. Okay, so first we're doing the addition. So 2 plus 5 is 7, and then we're doing subtraction. 2 minus 5 is minus 3, and then we're doing multiplication. 2 into 5 is 10. Then we're doing the division, 2 by 5. Since C is of type integer, it cannot take a fractional or a decimal value, okay, a decimal point, I mean. So ideally it'll be 0 point something here, but then it'll just cut it off, okay? It'll cut off the or truncate the decimal portion of it. So what you get is just a 0. If it was a floating point variable, if C was of type float or double, then you would have got 0 point whatever the correct answer is with precision. Okay, and then we've done the modulus operator, which should remain the which should return the remainder. So 2 by 5, the remainder would be 2. So C is 2 here. Now the pre-increment operator. See, in the previous statement, previous line rather, you've seen C's value is 2. Step we've done plus plus C. Okay, so first the value of C is incremented. That means it is increased by 1. As you can see, it has become 3 from 2. Okay, and then the statement is printed. Okay, whereas in the next step, we've given C++, which is post increment. That means first it has printed and then it would increase the value of C. So let's just give another print statement here. System.out.println C is equal to plus C. So what happened after the statement can also be tracked. Okay, so you can see after the statement has been, the value of C has been increased by 1. Similarly, with decrement, it's indicated with minus minus, okay, and equivalent to minus 1. Okay, so C here was 4. When I've done pre-decrement, first the value of C has gone down by 1 and then the statement has been printed. So C is 3 in this case. Next statement we've done post-decrement. So first we've printed the values, the whole statement has been executed first and then the value of C has been reduced by 1. So it has become 2 from 3. So that is the pre-increment decrement and post-increment and decrement. And then we have compound assignment operators, which are basically, suppose I consider this step. Okay, not this one. Suppose I have to do C is equal to C plus A. Okay. So I can either write it as C is equal to C plus A, or since C has been repeated both times, I can write it as C plus equal to A, which is same as C is equal to C plus A. Okay, let me write this in the comment section. Okay, and then we'll just print the value. Copy this full section. Similarly, you can use it with the other arithmetic operators too. So you can use it with plus, minus, and then multiplication, division, and the modulus as well. Okay, so we'll just run this. Okay, so till this step, here, C has become 2. Okay, after that, we know the value of A is 2. So C plus equals A is basically 2 plus 2, which is 4. Okay, so C is now 4. And then c minus equal to a is c is equal to c minus 1. That means 4 minus 2, which is 2. Now we're doing c into equal to a. That means c is equal to c into a. I'm sorry, I've not changed the comments, but I hope you can understand. So c is equal to c into a. That means 2 into 2, which is 4 again. And then c by a is equal to, sorry, c by is equal to a is same as c is equal to c by a. Okay, so that is 4 by 2, which is 2. And then c modulus equal to a, c percentile equal to a, whatever, is the remainder. Okay, so c is equal to c percentile a, which is 0. 2 percentile 2 is 0. Okay, and we also have relational operators. Okay, so initially our a is 2, b is 5. Let's just compare these two. Okay, so let me copy this. Okay, so relational operators are basically greater than, less than, greater than equal to, less than equal to, and not equal to. Okay, so let me check. A greater than b plus a, I'm sorry, greater than b. Okay, and then let's try with less than, then greater than equal to, and less than equal to, or double equal to. Single equal to is used for the assignment operator, okay, to assign the variable a particular value. But double equal to is used to compare the two values and check if their values are equal or not. Okay, and not equal to. The exclamation usually represents not. Okay, so let's just run this. Okay. So there's an important observation you need to make here, okay? The relational operators always return the value in terms of Boolean, Boolean type, okay? I mean true or false, okay? So when I say A greater than B, it's either true or false, and likewise with all the other cases. So you can just go through these, okay? India, I forgot to mention. As we've seen earlier, the plus operator can be used for two purposes. One is the arithmetic addition, and the other is for the concatenation of strings. Okay, that means adding one string behind the other string. Okay, like you combine the two strings into. And then we have logical operators, okay, which are again subclassified into bitwise operators and short circuit operators. Okay, so coming to bitwise operators, what they basically do is they take the binary value of whatever your data is, your number rather, uh, not necessarily a number, whatever your data is. So they take the binary value of that and perform the operation on every single bit on it. Bit by bit is what I mean. Okay, so let's consider, just a second. Okay, so let's start off with the bitwise AND operator. So A and B will basically perform, I mean, it'll take the binary value of A and the binary value of B, and then on each corresponding bit, it'll perform the AND operation. And then whatever resultant it gets out of this operation, that particular value is again converted back to your desk that is printed. So let's just execute this. Okay, so there might not be any matching bits. So similarly, let's try out with the other bitwise operators too. So we have AND, we have OR, we have NOT, and we have XOR or XOR. Okay, wait. NOT is performed on a single value. It cannot be performed on two values, right? So it still says semicolon. Okay, wait, I think I've not saved it. Bad operand type end for unary operator. Okay, so I don't think we can do this. So let's just take it off and check with the others. Yep. Okay, so and bitwise and has returned 0, OR has returned 7, and XOR or XOR has also returned 7. We also have the short circuit operators. Okay, so we have two short circuit operators which are and OR. I'll tell you the difference between bitwise and this short circuit operator. Okay, basically, suppose okay, let's consider these three. Okay, these three statements. Actually, just two. Okay, suppose we want to check if A is greater than B and A is greater than or equal to B. I know it actually does not make any sense, but let's just check it, okay, for the illustration purpose. So A greater than B and A greater than equal to B. So what basically happens here is the number of comparisons you will have to make to come to a conclusion would reduce. That's because when you know A greater than B, suppose A greater than B itself becomes false. Okay? False and anything would definitely be false. So you don't even have to go and check for the second condition. So it's actually saving your time. Okay? Similarly, with the OR, short circuit operator OR, what happens with this is if the first value, first condition itself is true, then it doesn't have to check for the other one, because irrespective of it being true or false, the resultant Boolean value would be true. The second condition would only have to be checked if this particular thing has become false in case of OR. And in case of AND, this is true. Then you'll have to check if the other one is also true. Okay, so let's just print this. Okay, so A greater than B and A greater than equal to B is false, which as we expected. Okay, and A greater than B or A greater than or equal to B is also false. Okay, let's just change this to less than and less than equal to. Okay, we might get a different result this time. Yeah, so this in this case it is true. That's it. So we're now done with the operators of Java.